You are working with the INRA, the French Agricultural National Research, what's AA for?
Culture.
Yeah, okay. International Institute. Yes. Okay, now, you are going to tell us that things are not that simple that we think. That's what I understood from your presentation, that we all think that just changing fossil fuels by using biofuels seems very, very palatable in the beginning, but when you look closer to it, it's not that easy. Please, the chair is yours, and you give a warm applause for a comment.
Thank you, Peter. First, thank you also for inviting me. And when we discussed with Matthew some time ago about what could be the topic for this presentation, I had just finished at the time study for the French Environmental Agency. So you have the front page here. You can download it from the internet, on the environmental assessment of biofuel development, taking into account land use and land use change. So exactly, that's, as Peter said, it can get, when you touch this issue, it can get a little bit more complicated than you could expect at the beginning. So first, as you may all know, biofuels have been supported in many countries for three main reasons. First, they are, and that's why we're here today, they have been presented as a way to mitigate greenhouse gas emissions by substitution of fossil fuel with renewable carbon or biomass-based carbon. They have also been presented as a way to support farmers' income and also as a way to diversify energy supply or promote energy security. Basically, the point of my talk today will be to show that there could be some trade-offs between the first two objectives of biofuel developments, especially if you take into account land use and land use change. So biofuels and land use change, what's at stake? From an economist, I'm an economist, I should have said before. From an economist's perspective, biofuels are just an additional demand for agricultural products, meaning that an increase in demand for agricultural commodities will lead to a price increase in equilibrium. And then higher prices will prompt higher incentives for farmers to increase their outputs. That could be domestically or in foreign countries. And that could be for crops, for biofuels, of course, but also for crops for food and feed, for instance. And basically, you have three ways of meeting this additional demand. You can either intensify your production, for instance, use higher amounts of inputs and increase yield. You can have some substitution occurring in the system. Higher prices tend to decrease demand. You have byproducts that can save land somewhere else and so forth. And you can also expand agricultural area. And that's really the third one that I will focus on in my presentation. So let's start to illustrate that. Let's start with total area here on the picture, split it into forest, grassland, and cropland, both for biofuel, food, and feed. And imagine that there is an additional demand for biofuel coming up. Basically, this additional demand will cause land use change both directly and indirectly. So the direct part is just that you will have some land converted toward energy use, either in Sweden or in France or far away, to produce biofuels. And that's what I call DLUC on the picture here. But also because you have higher prices and you have some cropland that is displaced for energy purposes, you will have also some indirect land use change, that is, land conversions toward non-energy agricultural use. And that could be also domestically or abroad. And that's going to be called in the rest of the presentation ILUC. The problem is there are many factors influencing land use and land use change globally. And it's very difficult just from just from looking at historical observations to isolate the biofuel effect. So what you have to do if you want to see what is the effect of biofuels on land use and land use change is to use models that can contrast simulations with and without development of biofuels. And actually, this kind of these simulations have been done in a lot of studies recently. So now, if we go here, the different land use changes category that I figured on that are on the picture here, they may have different, very different impacts on carbon stocks. If they occur on peatland, for instance, they can have a massive impact on carbon stocks. But if it's just about diverting area that is used to grow corn, for instance, for food or for feed before, to ethanol, well, the impact on carbon stocks is not that big. So the problem in the comparison in terms of greenhouse gas emissions between biofuels and fossil fuel we have is to account for that. So basically, most of the life cycle analysis of biofuels rely on the fact that the substitution of fossil fuel by biomass-based carbon enables emission savings compared to the fossil fuel. So that's the difference here. But then the problem is to have most of the life cycle analysis stop actually here. The problem is, what is the impact of the land use changes that we've identified before on these emissions, both direct land use changes and indirect land use changes. And actually, we have three problems there. We have a problem about the size of this effect, namely, do these land use change effects increase or decrease greenhouse gas emissions? They can decrease greenhouse gas emissions or increase carbon stocks, for instance, if we rely on perennials. Or they can increase if they involve more land conversion to forests. Then we have a problem of magnitude. If they are positive, are these land use change effects likely to be bigger than the emission savings that we expect from the substitution of fossil fuel? And then, as we will show afterwards, we have a problem with uncertainty, or what I will call viability, actually. If you look at the available estimates out there of this effect, you have a very large viability, and I will illustrate that in a second. The problem is this viability a reflection of a true uncertainty, or is it a reflection of differences in assumptions or scenarios? And that's going to be the topic of the rest. So to do that, what we've done for the French Environmental Agency is to look at all the literature we could find on the topic. And actually, so we took a lot of, all what we could possibly find on the topic and extract the studies that actually provided a non-redundant, transparent, quantitative evaluation of these land use effects. And we ended up with 71 studies. Among them, 49 provide a total of 560 estimates of this total land use change effect on greenhouse gas emission of the development of biofuel. And when you look at the results, here you have the distribution of the results, so we had to harmonize all the numbers that we collected and everything. I skipped the details, but when you look at the distribution of these results, what's striking is the viability of the results. You might see the range here, but it goes from minus 300 grams of CO2 equivalent per megajoule to 2,300 grams of CO2 equivalents for the total land use change effect. Even if you zoom in, that's the same numbers, but zoomed in terms of distribution, it's pretty large if you compare those numbers to, for instance, the emissions that are due to burning fossil fuel. Fossil fuel, if you take the default that is in the European directive, causes emissions of about 84 grams of CO2 equivalent per megajoule. And remember, we have a range of minus 300 to more than 2,000 grams of CO2 equivalent, just in terms of land use change. So huge viability there. Same results again, putting all together, but now the cumulative results. That's the same distribution. What you can see here is that among the 560 points that we've identified, 87% of them are positive. So that's So much for the sign, the first question that I put forth in the first slide. 54 are above the 50% reduction threshold put forth by the Commission. 44 are above the 35% reduction threshold put forth by the Commission. And then more than a quarter of the points actually have emissions that are just due to land use change, that are bigger than the fossil fuel of reference. So not good for these points. And again, that's just the land use change effect. Now, if you add up the emissions related to the production of the feedstock, transportation, transformation, and everything, it's 52% of the points that we collected that are above the fossil fuel in terms of greenhouse gas emissions. Having said that, actually we haven't said much, because the environmental assessment of biofuels is not to be decided by a majority vote. We have other opportunities to do majority votes, and we had one recently in my country. But that's not the topic here. Actually, behind these points, you have different estimates coming from different studies, coming with done with different approaches. Some studies are peer-reviewed, some are not. Some look at a very fine scale and very fine resolution, some not. Some look at this issue at a global scale. They differ also in terms of scenarios and assumptions and everything. So you have very different sources for these points. And the problem is, in drawing this picture here, are we comparing things that are actually comparable? So to address this issue, actually, what we've conducted in the study is some kind of meta-analysis. So we didn't do a new or another model, but we treated statistically the results that we could collect from the literature. And we used the various studies or models as controlled experiments in a statistic sense. And we have two objectives doing so. First, we want to quantify the effects of different assumptions or characteristics of the studies on the evaluation of the total look factor. And second, we want to estimate some kind of meta-model that allows to compare, predict results on all other things being equal basis. And that's the important part there. I won't go into the details of the results, but this is basically what the main results of the study. Here you have, for two subsamples of the points that we identified, you have the effect of different characteristics or assumptions that are in the studies. Some are related to the study status in terms of publication, or is it peer-reviewed or not. Some are about the fact or the issue of taking into account the substitution or intensification effects, the types of land use change accounted for in the study, the type of biofuel, that's an important one, and geographical coverage, and the fact that the study take into account or not second generation processes. So what you have here, maybe you don't see the range, but you have the specific effect or the effect of different characteristics in terms of grams of CO2 equivalent per megajoule. So you can also compare with the 84 grams of CO2 per megajoule due to fossil fuel. Let me just illustrate with one characteristics here. For instance, this share of ethanol variable here. What it tells you is that one study that considers a 100% blending of biofuel, of 100%, ethanol biofuel as a look factor that is on average, if you look at the left picture, on average 15 grams of CO2 equivalent per megajoule. And so forth. Let me sum up the results there, because I see Peter going up, so I guess my time is almost over. Okay, I will do that one. So I will skip that one and I will go there. So what we find here, the main findings in terms of determinants of the total look factor. First, the approach matters. We find differences between economic models and more engineering-based consequential studies. The economic models find larger look effects than consequential studies do. The type of biofuel matters. Ethanol is better than biodiesel with respect to greenhouse gas emissions. And also second generation, as we expected, is better in terms of emissions than first generations only. The type of look of land use change considered matters as well. If a study that takes into account the peatland effect that we've heard about in the first presentation finds more emissions due to land use change than a study that does not. And lastly, market mechanisms also matter. If you have endogenous price effects, that means that, for instance, yields respond to higher prices, or demand also decreases when prices are higher, then you need less land in the end, and then you have less land use change related emissions. So if I go back to the conclusions or to the 3 question marks I had at the beginning about the science, well, you saw the distribution with almost 90% of the data points we identified that had positive land use change factors. We can conclude pretty safely that land use change effects tend to increase greenhouse gas emissions. So they should be accounted for in the assessment of biofuels. And that's an important topic right now, especially at the Commission on this issue. In terms of magnitude, I didn't show the results about the predictions, but we find, using the model that we estimated, we find a total look factor of about 72 grams of CO2 equivalent per megajoule for the European context. And again, that's just for land use change. That's not for producing the feedstock and transforming it and so forth. So there is an important risk that biofuels may be worse than fossil fuel with respect to greenhouse gas emissions. So that's for the magnitude. And then about the uncertainty. The uncertainty is sometimes used as an argument to say, we don't know enough about the land use change effects. We shouldn't be doing anything because we don't know enough. And if you look at the raw results, in effect, you have a lot of variability. But part of this variability comes from differences in assumptions, in characteristics, and so forth. And when you control for these differences, you see that the uncertainty, there is still uncertainty for sure, there will be. But it's much less than you can expect at the beginning. So variability alone cannot justify an action about land use change effects in the environmental assessment of biofuels. And I stop here. Thank you.
Thank you very much. Please let the picture be there, because I think that's a very exciting. And a direct question from the, oh, there are so many. Where is the microphone? First, yes, please.
Well, I think that there are many studies that contradict some of your results here. For instance, there's a British study showing that if you produce ethanol from grain and the protein feed is replacing soybean from Brazil, you have a definite positive eye-look effect, indirect effect. But you have to use modern technology, and I think that some of these studies are using, comparing bioethanol with an ineffective system. But I think the major problem is that you want to send the signals, the right signals to the producer of biofuels to do the right thing. But if you put any type of fee or tariff on for eye-look, there's nothing that the individual producer or biofuel can do. Don't you see that as a great problem?
It is.
You have to say that if you do the right thing, you will get a benefit. If you do the wrong thing, you'll get punished. But if you have some type of fee based on a theoretical model, there is nothing you can do than stop producing something to replace fossil fuels.
Stefan,
Okay.
comment.
First, on the British study, they're taken into account in the distribution here, and you can see them on the far left. And what you see is that if you look at all the results that are negative in terms of iLook, or total look factor, actually here, those ones here, that's very interesting because they all come from none of them come from economic models. All of them come from what I called consequential studies. And all of them actually require some very specific assumptions that we detail in the report to obtain these negative results. So that's possible. That's possible, especially because of the byproducts, as you mentioned, and then the substitution in the animal feeding systems. So that's possible, but admittedly, they're a minority of the data points that we collected, and we have good reasons to think that they're over-optimistic if you take the full picture. So that's the first point. And second point, you're right. I mean, that's a real problem to implement based on that. The problem is we've pushed so hard biofuel policies as a mitigation option that now we have troubles when we account for the full effects of these policies. And of course, the best would be to have farmers, including their land use change effects and carbon emission content of their production into their decision-making process. And we're far from doing that. But the problem is we cannot, well, yeah, that's the problem. We pushed these policies for mitigation purposes, and then the indirect effects can prove to be worse than what we intended, what we pushed for in the beginning.
Sorry, we already...
No, the only thing that's possible to do is to have a carbon signal globally, which we are not ready to do right now. But the problem is, if you want to promote biofuel based on mitigation, then the indirect effects may totally destroy the argument.
Because we can't keep this discussion going on too long. Stefan will not be on the panel, so we will use a few minutes more to have two comments from Jan Gerhard, yes, and sitting besides you, and take those comments directly, and then you will...
You named it. There is a risk that the cure is worse than the disease. Couldn't it be possible to have a life cycle analysis standard? So all life cycle analysis took into account not only tractor fuel and natural gas for fertilizer and so on, but also that the whole infrastructure, every machine in agriculture and forest must also be maintained and renewed in a fossil economy.
Just save your comment till the next question or comment come in there, and then you conclude.
Okay, well, I'm not a specialist of life cycle analysis, but I believe this part of renewal...
Stefan, couldn't you just wait a minute? Did you get it?
Oh, sorry.
Yeah.
Yes, I'll make a question.
Yeah.
On your assumptions. You said your assumptions are the same throughout. If you grow maize on a 10-ton per hectare field in the US, or you do maize on a 1 ton per hectare field in Africa, it's the same assumption. You don't see for Africa, I'm talking about Africa in particular, that there's a huge need, like we heard, to increase productivity. That in Africa, biofuels could be one way to get money into the agriculture in order to increase productivity and thereby use less land. So
That's
your assumption that you always take more land, is the assumption correct, that you always look at additional land when we have an enormous deforestation in Africa driven by low productivity?
That's true. That's
Okay. Please,
So-
the two comments.
So first on life cycle analysis, I think it's taken into account in terms of maintenance and renewing the material and everything. So I'm not a specialist of life cycle analysis, but I'm pretty sure they do that well. The problem is about the land use change effects that they have big troubles to include. And on your question, no, that's completely true. And I didn't go through the details of the equations there, but basically we take that into account because we contrast the studies that take into account the fact that productivity reacts to prices, and that's basically your argument, and studies that do not. And we find a pretty strong effect. Here you have it here. Here. You have it here. The studies that take into account the fact that productivity increases with prices find a much lower effect, of course, because we save land. It's the same for demand and the same for the production of co-products. And also we take into account, that's very rough because it's very difficult to put together all these studies, but we took into account the differences in the coverage, in the geographical coverage of the models.
Thank you very much, Stefan de Cara. You'll get a warm applause again and a little present.